Hello, everybody. Just getting everything up and running. Last minute questions. It makes it a little bit challenging because I'm hit up with questions as I'm trying to get streaming on 3 different platforms. Hopefully everything is working. Let's see here. How about that? And I think we're live over on YouTube as well. Hello, everybody. And we'll hit the transition here. Yep. Okay, that's good. Good to see. Somebody's replied. All right. So I'm going to say hello in the corner here. One of the things today we're going to get into eventually looking at stuff actually in the Unity editor and kind of feeling around. So hopefully you do have Unity installed on your computer. If you don't, that's okay as well. There is a bit of confusion. This used to be easier, I think, in their generosity to kind of make all sorts of additional stuff available to students. They sort of have made the basic download process a little bit more confusing. You don't really need the whole student developer pack to develop stuff. That's all the extra stuff. So don't worry about that. You really, as long as you can get to the point where you've created an account and you have downloaded the Unity Hub, that's pretty much, once you're there, then the first time you launch Unity Hub, it's probably going to download Unity. Hopefully you download Unity, you'll wind up with the editor. You're going to, add Visual Studio. And it should seamlessly go through that. So if at some point it's already like led you through and gotten you to the download the Unity Hub, then you're in good shape. I think the last link that I posted in Discord, if you have the free version already installed, that means there is no separate free version from the full version. That's the version, basically. It really just matters what you're allowed to do with stuff once you build it. That's really what happens. I mean, even the personal version is the whole thing. Some of the online aspects of it, the number of teams, the online buildings, some of the asset management, some of the analytics and stuff like that, those are all part of the pro license kind of stuff. But the editor itself is the same. As long as you can create a project, you should be able to use it. With the student and personal license, you do get some Unity Team Collaborate seats. You may wind up with either 3 or 5. I think that used to be the difference between the personal and the student version, which isn't a problem anyway, because we're going to deal with basically for now teams of 2. Team of 2, me and you. I use the Unity personal version. Probably could have used the student version, but that's just the way I've been a Unity personal version user for years and years now. So maybe that clears that up a little bit. So I've got 1, 2, 3, 4, 5, 19 people here. Okay, we got a quick question. Quick question from Sid over on Discord. Yes, that should be fine. If you don't have a school account, I don't know if they look for like an edu in your email or not. That might make it easier for them to say, yes, in fact, this is definitely a student license versus a personal license. Someone said the school account uses the GitHub student pack, and that's probably, so if you can use your RPI ID, it's probably better. It's not like there's going to be any kind of official link between the two. We don't really use it, since you'll notice we don't have Unity. Well, we're not using Unity on a lab computer. So everything we're doing in this class falls under just sort of the normal Unity educational license, but not with regards to an institutional license, right? So we're using Unity all kind of independently under both the personal and educational license here. So this isn't really a direct relationship between RPI and Unity or something like that, so you don't really need to worry about it. But signing up with your RPI edu email address might make some of the the stuff easier if you are going for the Unity GitHub student pack and so on. So that's easier, or just another thing. For the main thing right now, all we really need, like I said, is just if you've got the Unity hub down and you're able to launch a new project from there, you're good to go. If it does ask you for an account, you can either create an account, or I think I've always explicitly created an account. I'd imagine you can just go ahead and use your Google account, or I don't know what other platforms they allow you to authenticate through these days. Mm-hmm. Okay. Yep. The one thing I would mention with regards to that, depending on your laptop these days, one of the optimizations is a lot of time you'll get a laptop with like a solid state internal drive, as opposed to, you might have some secondary storage that's a normal spinning platter, or your external storage might even be, a USB stick or something like that. And so there's going to be kind of a hierarchy to how fast and accessible some of these storage options are. My personal recommendation would be to be careful whenever you're storing data. So if you're storing, anything from papers you're working on to even potentially your Unity projects, you might want to put those on an external device or a slower, spinning platter, as they say. But if you've got an application that you're using all the time, like, whether it's the Unity editor or I know the Unreal editor takes a lot of space, but it also can be really, really slow to start up if you don't, kind of optimize around it. But your other applications and things, some of the time the recommendation is to put, your applications, obviously your system and stuff would be on your fast, your SSD or your main hard drive that's kind of meant to be, your system drive. So that's one consideration, but definitely you're on a good track with regards to like all your data, which tends to be the thing that in the end takes up, a lot of space. I mean, certainly you can go overboard on applications as well. But what I usually recommend is, be careful about how you keep track of things, but for best kind of performance and, things being nice and snappy and so on, system and applications on your kind of built-in drive, your fast drive, and then data on an external device or something like that. I think I have on my machine, I might have like a 500 gig SSD. That's the system drive. And then I have a 1 terabyte spinning platter. That's my kind of user data. And then sometimes I'll have, USB and other kind of things externally as well. It's a good question. It's a very good question. But yeah, things have gotten a lot. Anyway, there's lots of good options available. All right, so hopefully that will kick us off. Some good background information. Thank you, and thank you, Mark, for helping out on that one. So let's dive into things. Lots to cover. I think this morning I more or less ran right up to the wire, so we might wind up doing the same thing again. Lots and lots of fun. We're going to talk a little bit about, very open-ended concepts that are kind of typical game engine, game architecture sort of concepts that are going to be, once again, applicable to wherever you wind up doing stuff, but then also specifically how they're sort of implemented in Unity, and get a little bit of experience and hopefully kick off some of our very first programs in Unity, or at least, we're going to actually write a couple of lines of code today to make sure that things are hopefully running and you get the basic ideas down. All right, so assuming everything's working, you guys can see my, you folks can all see my slides there. I think we're ready to go. All right, one last question. Somebody is typing. Dylan, you're typing? Okay. You will definitely be using Visual Studio. Yes, you need to have Visual Studio installed. You shouldn't just use anything you want, because we're going to be using, there's two big features of Visual Studio. I mean, Visual Studio is tightly integrated with the Unity engine, and we're going to be doing debugging inside Visual Studio. So we're going to be actually attaching to processes and things like that, and that's going to be something we want to be able to use. And the IntelliSense libraries as well. You want to make sure that that is supported. So rather than try to figure that out in a particular IDE, it just works, quote unquote, just works inside of Visual Studio. So rather than, try to figure it out in any other environment, it's just easy to get it all to work. But specifically, the Visual Studio debugging is really, really cool. Let's see, hoping to use Vim since, well, at your own risk. Anything above and beyond the normal Visual Studio is really at your own. If you really are into that, some particular environment, you do that. But for everyone who's kind of getting at this the first time, highly recommend, definitely stick with Visual Studio. There's some good reasons to do that. It's very well integrated, jumping back and forth, attaching to processes and that kind of stuff. It makes life much easier, and definitely the IntelliSense will come in very, very handy. You'll see that today. All right. So let's dive right in. First, with a little bit of background. So we're going to be going, again, we're kind of going a little bit back and forth between conceptual stuff and the actual application of things. So, we'll do a little bit of review of some general computer science stuff straight up here. Let's review the coding big picture. We talked about, games, or any program for that matter, are made of rules and data. Generally, the rules are the functions that we're using. Function, we'll use it in a very open sense. Some people will get very specific about, functional versus procedural versus different types of programming. I'll talk about that in just a minute. But imagine a function as being something that takes some type of input, takes some type of variable, and then outputs something else that is essentially a function on that variable, right? Does something as a result of working on that number or that bit of data. Right? We have data, like for example, we have this name Maria that is stored in a variable called name, right? So you should all be relatively familiar with, things like, variables hold data, functions operate on data, we pass them as parameters, right? General concepts. One of the other big things that we need in order to develop programs, we generally need some set of rules for us to program them with. Basically, this is the languages that we're using. It's the syntax and semantics. They are determined by a particular language, and it's that set of rules that allows us to be productive and to make things do what we want it to do. So looking at this little this cartoon here, we have the instructor who's got surrender written up on the board there, and he says, well, what does surrender mean? And the student in the back there has his hands raised and says, I give up. Now, this could mean one of two particular things, depending on what information I, as the viewer, have. What do I understand this to mean? If I understand it, if I already know what surrender means, this cartoon means something very different than if I don't know what the word surrender means, right? If I know that surrender means to give up, then this is funny, right? Because the student at the back, now we have the tension between the two. We don't know, is the student giving up, which is surrendering, or is the student offering the answer, I give up, because the student knows what surrender means, right? Because I understand it. If I had no idea what surrender means, I wouldn't really find this cartoon particularly funny because I would just see the student giving up, not knowing what surrender means, and I wouldn't either. Right. So without the right context, without the right understanding and knowledge about what's going on, knowing what these things mean, what these collections of letters in this case mean, it's difficult to figure out. So in order to do that, in general, also, in addition to knowing what a particular word or phrase means, there's also going to be structure to the language. So here in this example, we also have a structured language, pretty simple. The cat sat on the mat, which has, of course, a subject at the beginning, an article and a noun, the being article, kind of something that's not super important. The noun here, in this case, being the subject of the sentence, the cat. What is the cat doing? The cat is sitting apparently, or already sat. It's in the past tense. So it's a state that's already been achieved. There's a preposition that is telling us more information about, something specific about how the cat is sitting or where the cat is sitting. In this case, the cat is sitting on our last noun phrase here, also article noun, the mat, right? So from this, I can tell the cat is sitting on the mat or sat on the mat, as opposed to the mat being on top of the cat, or the cat sitting next to the mat, or who knows what's going on, right? And because we have these agreed upon things, if this had said, the mat on sat the cat, could you understand that? Maybe. On the mat sat the cat. Now that, pardon the rhyming there, on the mat sat the cat. That works. And depending on, what version of Yoda dialect we are willing to understand, we can kind of still make sense out of it, because in this case, it's a fairly simple statement, and we have, enough of the sort of context and the idea that generally a cat is something that's alive and capable of sitting, as opposed to a mat, which is, more a furnishing that can't really sit. So we can draw some kind of conclusions as well. But it's all about the syntax and semantics that allow us to interpret something in a meaningful way and potentially, react to it if we needed to. Right. So that's the computer language, and how it's defined is what's defining these, syntax and semantics for us, so we know we can be explicit about what the computer needs to do. Now, there's lots of subtlety to this. Computer science is certainly a huge field. And what does it mean to be, a particular syntax or particular language or particular even paradigm of programming? There's lots and lots of them. So this slide here is really just a short glossary. I'm going to just mention some things. So what we're going to be doing in game programming is largely sort of a combination of bunches of these things, actually, depending on kind of what the purpose of a particular script might be, or, something that we're trying to do in the context of the engine versus something else. So this is some general CS kind of terminology I'll just throw out there. Any one of these you could probably write a paper about, but in this case, we'll just, keep them to one line, right? There are different approaches to programming. Generally, there's a declarative approach, which we say, well, declarative programming is sort of stateless execution of expressions. You have functions that just return values, operate immediately, and there is no sense of state within something, right? You just execute the current line you're on and you move on, sort of thing. This stateless programming, or often sometimes referred to as functional programming, right? There's a function that just keeps executing function after function after function. There isn't this overall, lots of state to be maintained, and maybe a function changes the state of the whole machine. That's more imperative programming, where if the function can manipulate some state as opposed to just operating and returning a value, potentially. So within that, even there's all sorts of, or outside of that, even there's different programming paradigms, such as things like procedural programming. If you hear that term, generally, and I'm going to talk about general terms here, not really precise, just so we have a rough understanding or agreement between all of us. Procedural programming often refers to kind of straight, linear, execution of one thing after another, right? This, then that, then the other thing, right? If you have a program, you read it from top to bottom. Perhaps you wind up calling functions, but even they are sort of executed in order, and you have this kind of straight, linear progression that you follow through, this procedure that is easily followed and you kind of move through. In functional programming, generally, we start to organize our coding, our programs into functional units that operate on generally on some given data. If something does not take a parameter, it is technically not a function because it doesn't actually, even it may perform some purpose or some function, quote unquote, but you can't have a function that takes no parameter, right? So that's kind of, anyway, it's a little bit, there's all sorts of sort of very, cheese to slice very, very thin if we want on here in terms of, being specific. There's also a term called modular programming. Okay, now not only do we have functions, but we can organize functionality according to similar purpose, right? So starting to organize functionality according to modulars or be modular, right? Big buzzword, big phrase here. I'm sure we've all heard object-oriented and being object-oriented or having object-oriented programming. Now, the big jump here is that unlike a lot of the other similar paradigms, this elevates data to the point where it is almost co-equal with functionality, right? There are objects that contain both data and functionality or some sort of capability that they operate and they stand sort of on their own, right? Units are not just functional, but are designed as independent entities, right? They're more like what we're going to see in Unity, but they're not. Unity, we're going to see objects. It's organized in this way, but officially object-oriented programming is, again, it's a huge topic of, it has to also have, officially it should have inheritance and should have encapsulation, all these sorts of things that kind of make things officially object-oriented. We'll get into that later as well. There's some other bits and pieces, some buzzwords to know about types and user interactions. If we talk about sort of automata-based or kind of polling or turn-based sort of user interaction or programming styles, that can be something that's heavily state-based. So sort of our imperative style programming where the program is in a particular state at any moment, like it might be waiting for input or prompting, what it has to do to prompt for input and then process the input before doing something else. So if we're using a polling or turn-based system, we're going to say, okay, prompt for input, wait for a response, process input, repeat, and so on. So whenever we need data, wherever we want something from the real world, we have to explicitly sort of go out and ask for it, or the program kind of goes out and asks for it and just kind of waits for it to come back. So it kind of, in many cases, that's a sort of a polling response. Just keep checking, keep checking the state of the mouse, the state of a button until you get the response you want or need or something, and then move on to the next thing. As opposed to event-driven programming, where you write your programs to be much more sort of responsive and reactive to events that occur. So maybe you're not waiting for the mouse button to be pressed or for a key to be pressed, but instead you write a method or a function to be executed in response to that event happening, as opposed to waiting around for that to happen. So functions are written to respond to predefined events that might happen often at any time, right? So we can say, oh, the mouse is clicked. Didn't matter that we happen to be in this state in the program when that mouse was clicked. We need to sort of drop everything and process that mouse click, maybe. Kind of. Well, again, these are all loose definitions for now. And there's also this notion of real-time programming, in which case code is not necessarily tied to a specific interaction with the user, but instead it is just sort of happening. This is the combination of kind of simulation and presentation in a real-time sense, right? If we're watching the program run, we're watching an animation that's being played in real time that happened because whatever reason, because that's just the world's state, right? That is running according to some clock, and we're getting a certain number of frames per second, and we're just sort of watching it happen. There may be input that we're providing as users, or maybe there's input that it's using, responding from the rest of the world. Who knows? Maybe it's looking at a camera and it's reacting based on what it's looking at. But everything is happening in real time. It's not waiting for an event, or it's not only reacting to an event, or maybe you have a real-time loop, that there are events that might change the behavior of that loop. So even these things are going to be, we're going to like layer these on top of one another potentially, right? You'll see in as we start to program, you may even use combinations such as you might reach a point in the program where you're going to suddenly, not suddenly, but you're going to pull for input from the keyboard as opposed to, or pull the mouse to see its position, as opposed to waiting or having an event that happens in response to a button being clicked. All right, so it's not unusual to be combining lots of these different techniques and paradigms as you're going. Right, this I find being flexible is generally a good thing. All right, so some great terms in here. I wouldn't view these as strict definitions. Don't use these as responses on exams outside of this class. I would think you can use them to be inspired. But anyway, so another thing. So what is the difference between the language and the engine? Okay, so in Unity, we are going to be using C#, but Unity was largely written in C++, I believe. But the engine, what does it mean? So we're going to be using languages in there, but the engine is going to be providing a lot of things for us that we don't have to implement. Normally, when I talk about game engines and game architectures and so on, I say, well, an engine might be a collection of code. It might be a set of templates. It might be an elaborate environment like Unity where the things are already built and you can point and click and build and so on. So an engine can be lots of different things, but generally, the main thing is that an engine is going to abstract a lot of the grunt work from development. It's already going to be, providing you certain things that you don't then have to worry about. It may have a built-in physics library. It may have a built-in graphics capability and audio and animation and so on. So it's going to take some level of functionality and kind of present it to you in a way that you can then just sort of take advantage of it. Often that's working at sort of an object level where we're creating objects that somebody else has already created behaviors for, created functionality behind. And we can operate at this sort of maybe point and click level rather than a coding level. Most of the things we do inside of the Unity editor or the Unity engine, as we're pointing and clicking, it's going to be that sort of pointy clicky kind of thing, connecting and by dragging things on top of one another or setting them in a timeline and so on. Sometimes hooking code to buttons and putting components on objects that run code and so on. But it's largely at that kind of pointy clicky level when we're in the Unity editor versus the Visual Studio editor. So I've already mentioned the term object a whole bunch of times. So what is an object? Well, there are Unity game objects. They are sort of, they're designed, of course, to be sort of standalone and carry a certain amount of functionality, operate on their own, and live within a hierarchy and so on. It's has certain object-oriented-ish feeling features, kind of, sort of. It's not exactly what we think of when we strictly talk about object-oriented programming, but we're going to see that term object used a lot. And normally it means something that has some kind of standalone functionality of itself. It is that sort of entity. An entity is a word that a lot of engines do use in place of object. It could be an entity that lives in the hierarchy of the game. So that's what that can be. So imagine we have the game object or an object, and let's think of it in an object-oriented programming sort of sense. Right. And most of the time, one of the fundamental things about object-oriented programming is it is objects that contain both rules and data. Right. It's functionality of how to operate on certain types of data and potentially to do certain tasks that the computer at large or the program at large needs to do. So it may very well hide things within it. And by hide, I just mean like it'll say, all right, it's got data that it needs to operate on and state that it needs to maintain, and even functionality that might need to use within it that by general practice, we're going to keep within the scope of the object, right? Often we have this functionality built in, and we want to be careful about how we expose that functionality or that data to the outside world or to other objects or other scripts or other programs, right? Because we want the object to be something that stands on its own. It's a unit of it's a unit that makes sense in and of itself, right? So we have rules inside there and data. What might that be? Maybe let's give a concrete example, or sort of a semi-concrete example. Imagine the object we want to talk about, the game object we want to talk about, is a cart in Mario Kart. Okay, so was the interactive part of class today, one of them. Give me a couple of examples. I have a better sheet after this, but give me a couple examples what you might think of as being some of the rules that you might need, or the procedures that you might need to do according to a cart, versus, or including also then the data that might be associated with a cart in Mario Kart. Anybody? I have a little drink here from my beverage. Anybody? Okay. Yeah, drifting ability would be absolutely one of them. So yeah, there's all. That is a good one. So it might be able to, the method, or the rule might be, how to drift. Okay, and then drifting depends on what? The weight of the car, the responsiveness of the turning, the state of the tires, all that sort of thing. All right, so those would be some rules that would affect the car's ability to drift, and drifting is something the car could do, right? Yes, that's a very good and very explicit example in terms of exactly the sort of kind of detail about these sort of rules and behavior. So that's absolutely correct, though. The blue shell potentially is an object, and we get into a little bit of we'll talk a lot more about like hierarchy at some point. Kelly mentioned, I see on another response, about like power ups. Yep, and it might very well be are you holding a power up? Which power up do you have? How do you work with a power up? So that might be. Do you have an inventory list of power ups? Maybe. And then there's other things. Oh, we have lots and lots of good response here. Speed, acceleration, weight, handling, traction, drift type, off road, turbo. These are all sorts of the data that are going to be defined. Some of them are going to be characteristics, right? A lot of the data is going to be the characteristics. How fast can it go? What is the top speed? What is the current speed? What, and so on. And then there's going to be functionality. Yep, looks like Kyle has mentioned here, accelerate forwards, accelerate backwards, turn, brake. These are the verbs that we're talking about, right? So to change between different cart states, depending on what part of the track you're on. Okay, that's pretty good as well. Now we've got some complex environmental interactions going on. So we're kind of, now it's interesting. And even with the case of the power-ups, there's going to be these kind of areas in between where this object is going to need to interface with other objects as well, right? It may wind up maybe even containing another object, like maybe a car has wheels, and maybe wheels have certain behaviors, right? So let's see, the character on the cart. Yeah, what character is sitting in the cart, right? Maybe some relationship depending on how, it might be as simple as saying a pointer to another object saying, yes, this is the person in the seat. And then that character has a whole nother set of behaviors and data associated with it. The hitbox, very good one. There's some kind of physics-based, something around the character. Maybe it's the same thing as the mesh of the car itself, or maybe it's a crude rectangle that we use then to figure out how it interacts with the environment. And let's see, remember that often the stats that the game shows to the player often affect the actual mechanics very differently. Yes, to dumb down the rules or just obfuscate it. Absolutely, yeah. What's presented the end result is quite often much simpler than a lot of the things that are underneath. You can think of it this way: when you're driving a car in the real world and you're presented with a steering wheel and an accelerating, pedal and maybe a stick shift, the amount of things that you're doing versus these days with very complicated electronic systems, and certainly with all of the stuff that's, doing lane correction and adaptive speed control and so on and so on and so on, there can be very sophisticated models and sophisticated data and rules that are being run underneath the covers versus how they're presented to the user. Okay. Did they remove drift types? I don't know. We'll have to we'll jump off from there. So the idea, we're going to use some specific things there. But thank you all for your responses. Very good. All right. So let's think about the cart again for a second. All right, so we have a bunch of things here. We have the position of the cart, we have its turning rate, its maximum speed, its velocity, its intersection boundaries. And people have mentioned the hitbox. So that's what this might be, how it might be bounded by, what it bumps into. It might have a sprite image, or it might have a polygon mesh. Who knows in this case? It's going to have a certain acceleration rate. It might have the current item, the power up that it has. It might be the angle that it's at. It might be a set of angles. If it's, just a two-dimensional and has a rotation, maybe it has a rotation, pitch, yaw, roll. Who knows, right? Those are the kind of characteristics. And then on top of that, or in addition to that, I shouldn't say on top, but interacting with all of those different things, some more than others, are that functionality like that: braking, moving, turning, displaying, playing a sound, deploying an item, skidding, drifting, and so on. Right. So we have these rules, and we have rules and data, and they're just in this big kind of mess right now, just this big mush of things there inside the object. But the question is, maybe it makes sense to organize these things a little further, right? And modularize these things a little bit further, at least these concepts, right? Yes, we're slowly moving in that direction. We're going to talk about components. All right, Mark's jumping ahead. Here we are. All right. In Unity, an object is a container for components, largely. It has certain things built in. Don't worry, this is good. We always have varying levels of expertise already in the class. So within objects, or hanging off of objects, or being part of the object hierarchy, an object will have components associated with it. And often in other game systems, we talk about an entity component system. In Unity, we have these objects that act as containers for components. Right? What a component is actually an instantiation of a class. We can kind of think of that. Right? As we get into programming and scripting, we're going to be using our C# classes. That is right. Yes, at a really low level, a component is just another object, depending on the system. In some game engines, it is pure that way. In the case of Unity, game objects have a little bit more stuff that, like a component has to live on a game object. A normal component, a mono behavior, has to live on a game object because it's going to inherit certain things and have certain interfaces. So conceptually, and an engine like Godot actually is more strict like this, where components and objects really are closer to being exactly the same thing. And just, it's, as we say, turtles are all the way down. You have objects on objects on objects, and that's the way they work. There are a few things we'll see specifically in Unity that isn't exactly like that, but it's close, but it's very close. Okay, in Unity, objects are containers for components. So components are generally, and the ones that we write specifically, are C# classes that inherit from mono behaviors, which allow us to basically act as full class or first class citizens in the component world as far as Unity goes. Right. So in the cart example here, the cart is going to have certain things like a component that is a transform. Now, all game objects have sort of hard baked into them. Game objects have a transform on all of them. And that's one of the kind of weird, quirky things, as opposed to being pure objects like other systems. Okay, so A game object always has this sort of transform component built into it, and that component is the one that, yes, some of Mark was saying, I mean, yeah, just about every level of abstraction in C# comes down to layers of objects. Yes, yeah. We'll be having all sorts of fun with that. We'll get into scriptable objects and other special cases and non-mono behaviors and so on, depending on how we want to go there. Okay, so the base object has this component kind of hard baked into it called a transform, and the transform has a position which we're always going to have an X, a Y, and a Z. Even in a 2D game, you're going to have an X and a Y and a Z. So we could have a whole sidetrack about general object-oriented, argue about C++ versus C# versus Java versus, really cool stuff. But all right, so in the core, we have, every game object has this notion of having a position somewhere in the game world, even if it doesn't need to. It's kind of, the object is going to have that, right? There may be some very abstract things that still we wonder, why do they have a position, angle, and size? Who knows? But position is an X, Y, Z location, and if it's a 2D game, yes, if you have a 2D game, we're just going to use X and Y, and Z we're going to mostly ignore, except in certain circumstances. Sometimes it will come back to haunt us just a little bit, but let's just assume we're only going to use mostly X and Y in the case of our 2D game. But that is going to establish our position. That is going to establish our position in the world that the camera sees, right? In a world coordinate system. We'll talk about different coordinate systems a little bit, but for now, we're just going to have an X, Y, Z, which is a world coordinate system position for a game object. We're also going to have a set of angles, and we'll put a pin in that one. We can come back to that as well, where the set of angles determines an orientation or a set of rotations, or maybe a single rotation within the world. Imagine you have an object, you have your car on the track. It has a position on the track, but you have to figure, okay, is it facing forward? Is it spun around? Is it facing sideways? Is it upside down? Those things like spun around, upside down, and so on, that is the orientation, sometimes referred to as pitch, roll, and yaw. Or sometimes we just start, X rotation, Y rotation, Z rotation. Or if you want to get really fancy, we can also talk about quaternions, which is a far more advanced mathematical way of representing an orientation. Right. That one we're really not going to go into depth in, not an intro to game programming, but it's something to be aware of because we will see them. These things called quaternions. And it also has a size or scale, right? So any object can be scaled in terms of X, Y, and Z, scaling along its different dimensions. So that's something that every game object has built in and doesn't require an actual separate component, but is baked into the game object component. The other components, though, are going to be largely sort of situational, depending on, not just situational, but kind of design of the object itself. They're going to be appropriate to the particular object. So it might have a sprite renderer, which has some display functionality and the actual sprite images. It might have a rigid body 2D component, which is then going to use the hitboxes and the boundaries, the velocity, and some behaviors like the collisions with other objects. We might have some components that are entirely written by us, like the dark green ones here, the drive mechanics, for example. That's something that's not built in or not a standard component. So this is something we're going to build as either a C# script or potentially as a bolt graph if we wanted to, but they're going to be our custom components. We're going to design them. We're going to determine, okay, what is the data? What are the characteristics that we need? And what's the functionality that we need to implement? Maybe we have something like the item manager, which is our, currently keeping track of the current item that we have, and then what does it mean to deploy that item? How can we throw it, pitch it, and so on? And what sound happens as a result of us throwing it? Okay. So, all right. So let's practice this just a little bit. All right. Let's kind of review. With the game objects are the things in our game. We can kind of point to them. We should be able to say, okay, the enemy. that's an object. The player, that's an object. Those are kind of the general terms we're going to have. It might be a wall in the dungeon. It might be a creepy sound being emitted from somewhere. Sometimes it's not necessarily something that has a quote unquote physical or active presence in the game, but it's something that, has a set of behaviors and qualities and so on, right? They're the things in the game, and they tend to be independent objects, and they may very well be on screen or off screen. So in our example, we have the cart. All right. Then we have the functions, the rules, the verbs. They are contained within components that are contained inside of an object or on an object. So a function like moving, flying, wrapping around, blocking, aiming, etc. Properties, the data, the adjectives that are also contained there within the components. So you might have, for example, location, the position, orientation, health, ammo, and so on. Right? We associate them with a component so that we can do stuff with them. We can increment ammunition or decrement our health or change our location. Generally, these should be, there should be similar functionality and properties all kind of grouped together into components that make sense, right? Our next thing, containers to group related functions and properties. You add them to game objects. For example, transformer, renderer, collider, and so on. Now, events, we start to get, like I was saying in that other conceptual slide, events are a little bit squishier. They're a little bit, harder to pin down. Sometimes we have events that look like something very, very explicit. And there's going to be certain patterns of programming, certain techniques. We're going to refer to things that are specifically events. But here, let's refer sort of the squishy version where we're saying, okay, an event is a condition under which, or a circumstance under which something needs to happen. Some rule suddenly comes into play. We have to apply some function to a property on a component on a game object in response to some change in the environment. Something happened. That event happened, causing something to happen. A lot of stuff in Unity is going to be driven by an event, and we're going to be writing code in a way to sort of hang bits of code and reactions and methods off of these kind of reactions to events. So it might be an event like, oh, a button is pressed. I collided with another object, a frame incremented, or maybe even every second, or, someone moved a slider. Those are sort of events. So we might want to directly call some function to manipulate some property with that. All right. Examples. Notice the color coding. Hopefully that makes sense. We can, kind of see now we're talking, in terms of these sentences that make sense based on our objects and functions and so on. So if the D key is pressed, that's the event that we're worried about or concerned about or reacting to. If the D key is pressed, the player object moves to the right. That's the function. And moving to the right is really changing position. So we should, maybe that should say changes position to the right on the transform, right? So these are all things, establishing sort of the context in which things are happening. Every frame, all enemy ships on the screen move towards the player's position, right? That's a more complicated one where we have a number of different objects involved, right? We have the player, we have a group or maybe a collection of enemy ships that need to happen. And the event isn't just a single event, but it's happening every time the frame changes, right? Then we might have even more complex ones where we might have collisions, and each participant in a collision has the opportunity to react to that event on their own. And it might even say, well, okay, I know I collided with something. I need to assume I'm going to take damage, or I'm going to move in the opposite direction because I collided with something. But perhaps it might need to know what it collided with in order to take the appropriate action. Right. So sometimes objects are going to have these interactions with one another, even if they are a component. So sometimes we will be interacting with, one component maybe on an object, maybe interacting with another component on another object, or maybe even on the same object. It can get a little bit interesting. And last but not least, whenever the health of an enemy ship's control reaches 0, start over again. Whenever the health of an enemy ship's ship control reaches 0, destroy the ship, spawn an explosion, and play an explosion sound on its audio source. So we might have to do a bunch of things, a bunch of interactions with some other objects that maybe are properties or components on this control, or maybe they're on other objects, right? Whew. A lot of stuff, but we get the general idea now, right? There's hierarchies that we're going to be using and kind of common conceptuality we're going to be using in order to have those hierarchies work together. Now, all my courses, I'm always faced with this. I wish I was a pure computer science course, because then I would just say, well, let's just focus on the science of it, and we'll just, we don't have to worry about actually doing anything with this. We can just talk about these abstract concepts, but we can't. We can't talk in abstractions. We need to actually do stuff, because we are game programming after all. Now, in order to actually do stuff in Unity, we can talk about Unity concepts, or we can talk about programming concepts. We can talk about the C# part, or we can talk about Unity components. We're going to have to be kind of bouncing back and forth. We can't take a firm answer to the chicken and egg situation. We're going to need chickens and eggs in order to understand the process. I can tell you all about chickens and eggs as well, being someone who raises chickens. Anyway, so buckle up. We're going to focus on some concepts today, but we're also going to do a bit of coding. So I ask you to kind of, sometimes you just got to roll with it. If you have questions, ask them. But don't be surprised if we're not going to be super exhaustive into every finesse, every nuance of a particular thing. We're going to kind of move through things maybe a little bit quicker, which is why we have to wear our seatbelts. All right. Now, shortly, I guess maybe I'm going to go ahead. I'm going to turn off my camera. Maybe you've been paying attention to me over here in the window. I'm going to go disappear for a moment, because I don't want to obscure the interface here. So there we go. I'm going to hide a little bit. Now, those of you who are paying careful attention, you may immediately say, well, that's not dark mode, so that can't possibly be Unity 2020.2.2 F1. And you'd be right, this isn't. This is actually Unity 2019. And not only that, but this is actually Unity running on the Mac, right? So those of you who have a Mac platform, yes, I can feel for you, because I have done that myself. The platform, the editor, and so on is very, very similar across different platforms, and the structural organization is also still very similar today, so it doesn't change awfully fast, thankfully. But and most of the core concepts, we're just going to cover in abstraction today. So on the Unity side, that's where we're going to be sort of building things and pointing and clicking. It's the what you see is what you get, or what you see is what you hear, or the GUI side, the graphic user interface piece that we're building, right? It is the integrated development environment. So we're usually going to be, not usually, we're almost always, maybe we're always, except for when we jump over and we actually write scripts. But even then, we're kind of doing it within the context of launching it from the Unity editor. So when we're working in Unity, we're really starting from the Unity editor. So it's the hub of the Unity hub, that's another thing. Anyway, okay. So here's the Unity editor. You'll immediately notice certain things. We have over here a hierarchy of objects that are the objects in the current scene. Sometimes we have objects that have children objects. There are actually, a hierarchy. An object can have children, like, imagine you have a car that has wheels, right? Or a spaceship that has escape pods. That could be a case where objects have hierarchies of objects. You could have, a tree that has branches, that has leaves, and so on. You could go in that route. You go that way. So we'd see that within the hierarchy. Things like, these power-ups, these platforms, the enemies here, they would all be objects in here. We could see now there's some different zombies that have been created here, and there's a wall and a switch and grids and so on, right? That's the hierarchy within our scene, right? The main piece of hierarchy. Now, scenes contain objects. We talk about objects containing, right? But now scenes contain objects. In Unity, scenes are different than objects. That's another kind of wacky thing. In some other environments, we can even go further with our object orientation and say, okay, a scene is actually an object that contains other objects. Valid, and Godot does exactly that, right? But in our case, in Unity, we're going to think of scenes as being very distinct from the typical objects, right? Scenes contain objects. They're not going to have components on them. They're going to have objects in them. Okay, we see our scenes down here. You may or may not see a game window, depending on whether things are set up. The Unity editor is also going to look different depending on what version you're running, and you can always be reconfiguring it yourself. You can decide, okay, I want the game window here, or I want a locked version of the inspector over there, or I want to have the console window over here. That's going to change, but generally, we're going to have to be careful. You know, what we're referring to is going to be similar. So here we have the inspector, kind of by default, winds up on here on the right side, which is going to show us now we have the scenes, and within the scene we have our objects, our game objects. And if I highlight a game object, I'm going to see over here in the inspector the components that are on that object. So here's the player. The player has a transform. It also has a sprite renderer, which is determining what sprite it has. It has a script that is written by me. So I wrote the player script, which determines how the player can move and so on. Has an animator component on it, which is going to animate my sprites potentially. I have a collider that's going to help me with physics, so I can figure out, okay, what are its boundaries and how might it interact with the environment. I have a rigid body 2D that's going to be the main physics component that I'm going to use here. We're using rigid body physics. And I also have an audio source on our little player here, because the audio, the player can make noises depending on what happens to it. All right. So here we have a little bit more of our hierarchy. We have our project that we're within. We have scenes within the project, and we have objects within the scenes, and we have components within or on largely just a view over on your hard drive of what the project is really made up of. So let's jump off from here in a second. Hierarchy, yep, scenes, objects, components. And our custom components are generally either going to be scripts or potentially those bolt graphs that I talked about, right? So rather than worry about those too much, let's go ahead. I'm going to, try to shrink this down a bit. And I think I still have Unity running over here. Yes. All right. Now I've already created a project here. And this is the one we worked with the class earlier today. So what I'm going to do is I will collapse a couple of things. So when you start up, you're going to have a empty scene. So let's go and let's have an empty scene. You may have seen, let's go ahead and save that. So when you first come up, and let's see, clear that, it's going to look a lot more like this potentially. Maybe you have a scene and maybe you have a game window, maybe not. You might, I think you just have the scene window, no game window here. And you have something called just sample scene that's in the scene directory, right? Everything else is blank, but we have, of course, hierarchy. You may or may not have console. I think you probably don't. Let's see. General console. I'll get ask right here, or let's see. Close the console. There we go. Get rid of that. Try to make it more like this might be there. There's our scene. So everything's sort of blank. I'm going to double click on the camera, right? So you see, I can double click on things in the hierarchy to see, to get to focus on them and to see what they are. And sometimes it's going to alternate. If I double click, it's going to get, really just zoom in and show exactly what it is in the closest context. And if I double click it again, it's going to show me a little bit more about, the general context of it. All right. So sometimes you don't be surprised. Sometimes you're going to want to double click and then double click again, depending on what you're doing. All right. So I have this empty scene with nothing in it other than the camera. And the camera has a transform, which is its position in the world, right? Notice it's at the center. And this is one odd thing. We'll get into this in detail a little bit later, but the camera isn't flat on the screen, we'll just say. The reason the camera is at -10Z is because it actually is looking down onto our flat 2D game, but it is not on that same plane. If it was on the plane, it wouldn't be able to look at the plane. If we want to read a piece of paper, we can't be on the paper. That way, right? So we have to be, in order to read a piece of paper, we need that third dimension, even though the paper is two-dimensional, because we, as the observer, can't be on that same plane as the writing. All right, so that's why the camera starts off at -10z, so it's not on the same plane as the everything else in the game. All right. So now we have some real hierarchy here. Now, the project, if we want, after this, we could say, okay, let's go, and if I right-click on the scene and I say Show in Explorer, it's going to show me that, yes, wherever I was, this is wherever I've made the project. And this one, like we were saying before, this is on my data drive. So I have a Unity folder that contains all of my Unity projects, almost all my Unity projects. And then I have a folder that I've created to contain everything for spring 2021. And eventually your projects, I will wind up putting them, as I download them using the Unity editor and the Unity collaboration tools, I'm going to put them in this same folder as well. I also have a project called GSAS 2540_spring_2021. So it's a little confusing here if I didn't know that, but so here's the containing folder and here's the actual project. And the project is a folder. The project contains everything that's part of that, right? You'll see there's the actual assets folder, this assets folder here. It has generic scripts, scenes, sound effects. And your version probably only has scenes, right? I've created this generic scripts and sound effects folder because I want to organize things so I can find them. If you're not careful, you'll wind up with just everything all at some, one level, and it will be a mess. It'll be really hard to find things and debug things. And you may even have conflicting objects and conflicting scripts. And you don't want to get into that. You want to organize things early on so that you have some structure to it. Right? One cool thing about Unity is even if you decide to organize things later, generally 99 times out of 100, you can move things around and Unity will just automatically reconnect them for you, right? So if I happen to be using this blue zone explosion sound effect on a particular object in a particular scene, and I decided for some reason that I wanted to change the name of this sound effects folder, or maybe even create a subfolder in there of just explosions, Unity is nice and that'll, take care of that for you. So better to be more organized, and it's never too late to organize as well. So anyway, so one of the main objects I want to talk about and systems I want to talk about, because it's going to be important in our first game. Let's see, 334. All right, great, doing great on time. Is the Unity GUI system, the graphic user interface system, the HUD, the heads-up display of Unity. It's a very special thing that cohabitates with the actual game world, but provides us some way of communicating with the user as sort of an overlay. I like to think of it as being sort of when Iron Man is wearing his helmet, he sees, you see in the movies, they always have that, this really cool overlays and stuff that Jarvis, communicates with him, the status of the suit, and maybe some stuff about the outside world. Oh, it's really, really cool overlay stuff. So that's what I like to think of as being the canvas, right? This overlay that overlays on the world and provides me with some information. Maybe there are even controls on there, right? It's a controls like text, buttons, sliders, panels, toggles, images. So the things that don't really live in the game world, they're not the rocks and the enemies and the platforms, the things that are in the world, but instead they're strictly for giving feedback to me, the player, right? It might be my score, or some text messages, something like that, right? That sort of thing. So let's take a look at that, because there's a very, very special relationship between this canvas, which is not actually in the Unity world, or it's in the scene, but it's not in the world. So it's this kind of weird ethereal in between. It'll make sense in just a second. So for the sake of clarity, I'm also going to take my game window, and I'm just going to put my game window at the bottom of the screen here. So kind of split it here. All right. So I have my window up here and my my scene up here and my game window down here. Now mine is going to be a little different. You probably have now, if you're change the size, do this. Change the size of your game window. Now, as you're doing this, you'll notice what's going to look quite different on your screen. This box here, that is the camera, is probably changing aspect ratio. What aspect ratio is the ratio between the width and the height of that box, right? If you look at your television, your monitor, your output device, generally it is probably a 16 by 9 aspect ratio, 16 units across, 9 units up and down. So it has a fixed aspect ratio. Your phone, your mobile device may have a very different aspect ratio, but for now, we're only talking about sort of desktop games. So we'll start there, and we'll think about that as being the aspect ratio. So I recommend early on to set that aspect ratio. We're going to do that right here in the game window, and you'll see you probably had it set to free aspect, and it was doing all this kind of interesting stuff like this. If I set it to 16 by 9, now it's fixed. And that's important because as I'm designing the game, I don't want to accidentally put things, especially important things, outside the view of the player, right? And it may be in one position on my screen or designed in here, and then someone else may play it on their machine. I want to make sure it shows up in the right place, right? Make some generally good assumptions about aspect ratio. That 16 by 9 is the thing I'll use. All right. So now we've got the game screen, the camera sort of doing the right thing. Double click on that. I see the main camera here. I'm not going to change anything about the camera just yet. So let's put something in the scene. And what I want to put in the scene, I'm going to start off with some things that are going to be in that canvas because I want to talk about this relationship. So to put something into the scene, generally, I could come over here and say game object and create empty and so on, use that menu. I like to just come over here, right click, say create. And I'm going to create UI elements in here. And the first thing I'm going to do is I'm going to create a bit of text. So put that right in there. And you'll notice some weird stuff happened, right? Suddenly this new boundary box is there. And the text appeared down here in the corner. I don't see any text here, even though that's what my camera is looking at. The main camera does not show any text there, but somehow in the game, the text shows up there. Ooh, it's a mystery. It's all because of this relationship between the canvas and the camera. The canvas is an overlay on top of, or potentially on top of the camera, or a camera, a view, right? This can get much, much more complicated, sophisticated. But for now, we'll kind of do it a simple way. We're going to say, all right, we have the camera and we have the canvas. Okay, I double clicked on the canvas. Now I can see the whole canvas. And it looks a lot more like what I'm seeing down here. I see my text down here in the corner where it appears here. So this is what I would see in the canvas as an overlay, versus this is what the camera is seeing, this bounding box here. And the result in the game window is the overlay of the canvas on top of the camera view here. Okay, so that's the two of them working together. Let's set a few things to make life hopefully a little bit easier as well. We're going to look at a little bit at these canvas, and you may just want to accept this. These are my recommendations. Depending on the circumstances, you might do things differently. So we're going to start off. We see the canvas here. And the canvas has some components on it, one being a canvas component, the other one being a canvas scalar. So the canvas itself, we're saying it is overlaying screen space. It's a simple mapping right now because we only have a single camera. We can leave that as it is, right? If we needed to overlay a specific camera or overlay the world, we could change that. For now, we'll just leave it as screen space overlay. But the interesting thing will be this part here, the scaler, right? Because now watch what happens. Right now, by default, it's set to constant pixel size. And if I decrease this, you'll see that my text here is disappearing as I'm changing that size. Why? Because this is occupying fewer pixels, and I have said, yes, this must be a constant pixel size. So that potentially is confusing. What I recommend doing is set this to scale with screen size. Okay, so now, as I change this, you'll see it's going to scale it according to the overlay. All right, so it's always there at that appropriate location relative to my screen, relative to my, ultimately my camera view. All right, so I can zoom in on it here, and I will basically sort of, if I say, okay, here's the canvas, I can see that text position in the canvas versus here's my camera, which is my camera into the world, which obviously does not have it in and of itself, it doesn't have that text in it. It's really just the canvas that has that text in it. So I can grab that text, and I'll even move it around a bit. And I'm going to center it on the screen. And I'm going to come here and I'm going to put some new text. I'm just going to say hello. I can change how it is centered. So it's going to be truly centered on the screen. And I can do things like, say, make the font bigger. Too big, and it won't fit. If the text does not fit in the box that you have created up here in this, including rectangle, you won't be able to see it. So I want to make that text box bigger so I can see it there. All right. So there. Now I've got some text. It's in the screen, and so on. I can potentially add other UI elements. And the one I like to introduce next is, you'll notice, I should mention, as I added the canvas here and the text on the canvas, use regular text. Don't use Text Mesh Pro text. Just use normal text. Keep it simple for now. Okay. The next thing I want to add is also a button. So we're just using a normal button, not a Text Mesh Pro button. It put it in a default location. You'll notice it put it as part of the hierarchy of the canvas. The canvas has the text object on it and the button object on it. So these are part of this hierarchy of objects. And the button itself even has text on the button. Right? So it has created this further hierarchy. So we have a canvas with text on it and a button on it and a button that has text on it. So if I want to change the text on that button, I need to change it here, right? On that component, the text component on the text object, on the button object, on the canvas object. Whew. Wow. To me, there it is. The button. And I need to be careful. If I have this selected and I move this, I would be moving just the text. If I want to move the button, I make sure to select the button. Now I can move the button and not just the text on the button. So I can move it around. Okay. There we have it. We've created some objects. Now the objects we've created have been sort of predefined, right? We were able to pick them from this menu. They were UI objects. I could put other types of objects as well. I could put, 2D objects. That might be sprites. There's physics objects, tile maps, and so on. But I can also place empty objects which have nothing on them other than that one component that everything has to have, which is a transform. Now, you'll notice it put this object in the middle of the screen here, which is unfortunately way off in space compared to the camera. Right? So you want to sort of be careful when you just create an object over here as to where it put it. right? So if I double click on that, you see it's way over here, which is terrible. So we can see it's at a weird position here. I'm going to fix that. I'm going to say put it at 0, 0, 0. And now if I double click on it, there it is. And if I double click on the main camera, you can see there's my game object. I'm going to use the, let's see, I can have, let's see, a couple different tools here. Now, interesting thing, the QWERTY keys, when you're in Unity, I forgot to mention this to the class, the QWERTY keys are going to cycle you through your sort of tool palette up here, right? You've got your hand tool, you've got your move tool, your rotate tool, your scale tool. So this is how you're going to manipulate potentially these if you want to, not be typing in values. You also have a rectangle tool, and you can do your move, rotate, and scale of selected objects, and so on. So here we're just going to use the move tool, and you'll see I can grab that blue box and kind of move it around and put it right over there, right? So it's got a new position. So if I want to do something spectacular with that game object, I jump back to my display here and say, well, what's happening next to here? And that was time for one more thing. How about some sound? So I want to introduce you to this sound, the way to create sound in here, right? Because it's not a visual object. It should be interesting. Here we go. Now I could just say right click here and go, okay, audio, create an audio source. That is sort of the fundamental sound object, is an audio source. It's a game object that has an audio source on it. Created an audio source. Now, just to show you that audio sources or other game objects, you can create them. You do whatever you want. So here I created an empty game object that I want to call my audio source. I want to add a component to it called an audio source component. And lo and behold, my audio source and its audio source really are the same thing, right? It's just in one case, there are, this menu here are sort of predefined game objects that have certain components already populated on them that are commonly used, right? But functionally, they are exactly the same as, bake your own, put your own in the scene. All right, so I'm going to delete the factory audio source that it came with. And instead, I'm going to use my audio source here. Now, let's see what happens. In my game, I have an audio source, I have a button, I have some text, and I'm not going to say maximize on play. If I say maximize on play, it's going to blow it up when I hit the play button. So other things about the Unity user interface. You have your play, your pause, and your step. Mostly you're going to be doing play. Don't edit when play is running. If you edit when play is running and you stop the game, you lose any edits that occurred while you were in play mode. Over here, we'll get into these much more later. You'll notice the cloud is how we manage services, and also if we are doing things like collaboration, right? If we want to turn on collaboration, we connect to a service, we associate our project with a organization, right? Some of you may have already done this, but for now, we'll just kind of leave that. So once it is actually part of collaboration, then I can easily just click a button over here and it's going to push things up to the server for me. All right, that's what's going on. So we have our kind of editor palette, our play continue, and sort of our services and some other menus for layers and layout. So here we are, back over here. Let's hit play. That was our distraction. We hit play. The game is now running down here in this window. I can press this button and not much happens. And if I double click here on the canvas, you'll see it's going to click up here just saying that, yep, you've really pressed it. But not much interesting has happened. Even though we have an audio source in there, we aren't hearing anything, right? Because this audio source, we've put a component on it, but it just has its default characteristics, one of which is that it has no audio clip. Like an audio component in and of itself is not going to sound like anything because it has no audio to play. So I just opened a bottle of soda. I'll sip. We need to give it something to play in order for our audio to play. Now, I already dragged this in from another game. You can get audio from anywhere, and then if you want, you can just drag it. If I went to my other Unity projects, for example, here I have an adventure project and assets. Probably have sounds folder. Let's see, what have I got here? Oh, all right. This is I'm going to drag that one in here. Might take a second. Okay, so I've got 2 audio files in my sound effects now. And when I click on them in the asset folder here in the project, you see the import settings for the sound. And I'm not going to change anything here. I'm just going to use the defaults, and it does a good job. It's going to decompress it, load it into memory. It's just telling me what the current format is and so on. Won't worry about that too much. So I've got these 2 sound clips. And now, if I want, I have my audio source up here. I can assign one of these clips, a reference to that clip, to my audio source. So I'll grab this, drag it up here, and just say, all right, that's the audio clip. Now, looking at the parameters here, you see that it says play on awake, and that's checked. That means as soon as this object, this component, wakes up, it will immediately go into play mode. So if I press play here, cross fingers, might be really loud. Hopefully you hear that. You hear that? Okay, so the audio begins immediately. Are we all still there? Do you hear that? Anyone? Okay, good. Good. Yeah, there's it's the way it's set up, it's fine. Don't worry. As long as you know that something was happening for now, that's fine. We won't get into anything super specific on that. Yeah, it's a little bit tricky, the interaction between the OBS Studio and Discord versus getting everything over on hopefully on the YouTube video. It turned out to be. Were you watching the YouTube or the Discord? Okay, yeah, the Discord volume might not be as good as the YouTube volume is, because the way that, anyway, OBS Studio works. Remind me to fix that for later. Okay, so here we now have an audio source that immediately, we didn't even have to program the audio source to do anything. This is another one of those great situations where, I wrote Grand Theft Auto without writing a single line of code, because I just had my background music, boom, dragged it in, play on load, done, sort of situation. Now, perhaps I don't want that to happen, and for a sound effect or an explosion, I probably don't want that to play on awake, so I would click that off, and I'm going to go ahead and put my explosion on that. All right, so now my object is really my explosion sound, and it's not going to play immediately when it wakes up. All right, so we have a game object that I made from scratch. I had a few game objects that are part of the UI system that are now hanging off of the canvas. All right. Haven't written any code yet, though. I got stuff to happen when the game played, but I haven't written any code yet. So let's continue on a little bit here. Whoops. Present. All right. We had some sound, the very basics of sound. So we talked already about being organized in the Unity editor. And the next component, the next thing we want to work on is, of course, scripts. Scripts we're going to edit from within Visual Studio. People have been asking before, could you use some kind of external environments and so on? Ultimately, a script, a C# .cs file is just a text file that lives on your hard disk. So you could open it with any text editor, of course. Right? It just lives on your hard disk. But when we open it from within the Unity editor, it's normally set up to spawn, to open up Visual Studio, and it has this great interaction between there. So we're going to be doing most of our coding and debugging, and when it comes to typing, yep, we're going to be doing it within Visual Studio. All right, so that's where we're going to be. So let's write our first bit of script, but in order to do that, let's talk a little bit about the most basic syntax of C#. And this goes for C and C++ as well. Lots of other languages, that whole family of things. Generally, we're going to call a function. What we want to do is we want to call a function. We want to write the most simple program, which is, of course, printing hello world. Now, Unity has, thankfully, a built-in function to output text to the console. The console is a special place, a special magical place that we can easily get to and mostly use for debugging purposes. The console is really for our developer use, right? So we're going to have messages throughout the game as we're developing. We want to see, okay, what's the current, state of that variable or the real position or something, some message to us. We're going to use the console to do that. And the print function is actually shorthand to something more specific, which is debug.log. There's a bunch of debugging functionality built into Unity that we're going to use. Some of it is going to be more visual. In this case, we're just logging text to the console using debug.log, but by saying print. All right. So the basic syntax of a statement in C#, similar to other ones, is that you have the function name, and then you have a set of parentheses, just normal parentheses here, always in pairs. And that says, okay, someone's asking about when my office hours are. Normally they are between the two sections. So they would have been from 12 to 2. So otherwise, if you've got a specific question, just shout it out anytime. Probably won't get to it in the middle of class, but okay. So we print and we have an argument. So we have the function and the argument that we're passing to it, right? A function is something that operates on some variable or some argument or some set of variables. So the parentheses, always in pairs, executes the function and contain, in this case, the parentheses contain the data that the function needs in order to do its thing, in this case, the text to output, right? The argument is the part that's inside the parentheses, the data that we pass into the function, right? In this case, print expects semicolons, right? C#, semicolons at the end of a line. That means we have reached the end of a command, right? You may very well have some compound commands when you can have, we could have a something that forms this string or formats the string or does something inside. We're passing that instead of an explicit string and so on. We can get fancy, but for now, this is a very, very simple function call. We're going to hello world. All right, so let's write hello world in Unity. Some of you, this is old. Some of you, this is brand new. Maybe it's just a different way of doing it. Or maybe it's old, but you've never seen someone do it this way. Who knows? All right, so let's write a script. Lots of ways to create a script. So we'll do this way. We're going to say, okay, we have a script folder, and this could be any folder here. I'm going to go ahead. I have a generic script folder that I created. I created it by right-clicking over here, saying Create Folder within my asset folder. I'm just going to go to it now. Generic script. There it is. And I'm going to create a folder explicitly I'm going to create a script explicitly in that folder. And this one was Hello World. I'm going to create a C# script. And that script, and now this is a critical moment here. This is a very critical moment because when you create a script and name it, it is also creating a class within that script and naming it according to whatever it is you name this. So let's be profound here, and I'm going to name it Hello Unity. You want these to be distinct. Okay, if you're not, there are ways to be careful, but normally this is the name of this becomes the name of your class. So normally you want to just be proactive and make them distinct so that Unity knows the difference, that the button interaction class versus the Hello Unity class versus the Hello World class, they are different things. And you'll see up here, the script has been created public class Hello Unity, just like in this one, public class Hello World. And this one is a public class button interactions, right? So they're all there. Now you'll notice I can't edit over here. I can only see that it's being imported. So let's try to edit that. So the way to edit that, I can just double click on it and say, all right, double click. Visual Studio should pop up. If it's not already running, it will run and you'll see it come up. Now I happen to have it running in the background. So blam, it happened real quick. And it's showing me the basic structure, the default behavior, the default structure it inserts into a C# class, C# script for us here. It assumes we want to build a typical component. In order for a typical component to work within the engine, the component has to comply with certain things. It has to, first off, it has to inherit from a mono behavior. That's what's happening on this line. It does it for you by default. We'll talk a lot more about inheritance later. But for now, all you need to know is it needs to pattern itself after this thing called a mono behavior. And it's IOUR. I love that. It is also basically sort of including some other bits of functionality, which tell it what, this script, okay, where is it getting that thing that is inheriting from? And what other kind of built-in functions and built-in capabilities might we need in this script, right? Some include files, essentially. So we're going to say, okay, we're using system collections, collections.generic, and most importantly, using Unity engine, right? Built that in for us. By default, it puts two other things in here, the most commonly used events. The start event, which is something that happens basically when this component starts because it's in an active scene, and an update event, which is called once per frame. So every time a frame is drawn, or before a frame is actually drawn, but it's about to be drawn, or we'll get into that exactly when that's occurring later as well. This update gets called once per frame. Now, once per frame is a little bit of a kind of an odd thing to say because there's no fixed frame rate, right? On my computer, on my laptop, if I happen to be running on the built-in screen, it's 144 hertz. So 144 times per second, the screen updates. If you happen to be running on some sort of external monitor that is incapable of running at that rate, maybe it runs at 60 hertz. Right. So update is not always running necessarily at the exact same rate over and over and again. We'll get into that a little bit more later as well. So, but for now, I'm just going to delete it. I'm not even going to use that function. I'm not even going to use that event. I'm just going to use start. I'm going to say inside of the start routine, that's where I'm going to put my code. So when this starts up, it's sort of the main. I'm going to say, okay, here, print. Hello, Unity, you magnificent thing. And I remember to put a semicolon at the end of the line. And so now I've written a script that looks like it's correct. Start, print, sure should do the right thing. Now you'll notice up here, hello unity.cs, it has a little asterisk, meaning it hasn't been saved yet. So I better save it. Now, I'm surprised no one has asked me to do this yet. I'll make the font a little bit bigger so you can see that. So I need to save it. I'm going to press Control S. I'm going to save it here. And when I go back over to Unity, I'm going to just click over to Unity here. You'll notice it takes a second, reloads script assemblies, and just flashes through. It's basically in the background, it's sort of compiling the script, making sure everything's good, right? Everything isn't just interpreted, it's actually compiled. And now we need to see that console window. So window, general, console. All right, now the console is just, might be floating around, or maybe I'm going to park it here. I have to park it right there for now. Until my scene becomes complex, I'm just going to park it right there. You'll notice there's nothing in the console window. If I had any mistakes in my code, and let's go ahead and do that. We'll say, okay, hello, Unity. Blah, 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 blah. There's a function for you. Save that. Come over here. You'll notice it's going to compile C# scripts and say, no. That's not cool. I'm not doing that. Double click on that, brings me back over here. It says, fix that, damn it. Squiggly line under there, that's an error. Get rid of that. Done. Save. In a moment, automatically do the right thing, cleared out. We're done. So make sure to look out for that, right? if I get requests and someone says, my program isn't working, turns out you have a bunch of syntax errors and it's not compiling. That's the first thing to look for. Look in the console window to make sure that your program is doing the right thing. All right, so hello, Unity, you magnificent thing. I come over here to my game and I press play. And I'm hoping that here in the console window, it will say, hello, Unity, you magnificent thing. And yet it does not. I press the button, nothing happens. Now, I'm sure in this class, people are already, yes, Mark is already, let's see, Unity should also give you an error pop-up in the top right. There is normally, I think, down here in the bottom left in the console, I would see things in there as well. But, okay, that might be a newer thing. I don't know. Sometimes it does hide, though. It's always want to be sure. First thing to do is always check the console. If you edited your text, you edited a script, always have your console around. Console is your friend. It's your main debugging tool, your friendliest, lightest weight debugging tool. So, the streams I will post specifically as I'm doing live streams. Someone's asking about my YouTube channel. I have lots of streams. The newer ones, I tend to make them unlisted because it angers they anger a lot of my subscribers because I have I forget how many subscribers. So I make them unlisted and I will post them in LMS, right? So you'll always be able to find our current ones. The current ones, most useful places to look in LMS, that's going to be linked, to the particular one. Now LMS is combined between the two sections, so you may very well see both sections, which is kind of crazy, but we'll just deal with that. And I will post them in Discord as well, and there'll be a playlist. You'll have lots of ways to find them. All right. So anyone, I know, Mark, you know why I didn't see the output of my console here. I'm assuming. Why? So if nobody else says, yes, Dylan, perfect. Yes. The script isn't in the scene. The script isn't in the scene. And not only is it not in the scene, but it's not an object in the scene, right? You can't just drag a script into a scene. Let's see. Actually, it's been a while since I tried that. If I drag this, you'll notice, I can't drag it directly into the scene, right? A component can't live in and of itself. It doesn't know about just a hello Unity object. It has to live on another object. It has to be, it's a component of an object, right? So I could drag it onto an object in there. I don't want to do that. Instead, I'm going to create an empty object, and I'm going to call this one Game Manager. And this is going to be how I start to know whether or not people are paying attention, because this is one way I like to do things. Could be done other ways, right? Yes. A script is a class that is instantiated as a component, but it is not a game object, right? So in order to actually use it within a scene, I have to have a game object. In this case, I'm just going to use my game manager. Why? Well, because this hello Unity behavior isn't really something that's kind of specific to a real object in the world. So I like to have a game manager object for things that are sort of more esoteric to the game, right? I haven't assigned them a bit of functionality. I'm not quite in a object-oriented mode just yet. All right, so I'm going to go ahead. I'm going to take my hello Unity object. I'm going to put it on my game manager. I'll try to. Yes. I just right-clicked and created an empty object, and I just called it Game Manager. It sounds fancy. It sounds certainly fancier than anything, but it's just another object. You can really blow your mind. If you make a script and you call it GameManager.cs, it will give it a fancy icon for no other reason other than, gee, that's cool. It doesn't really do anything other than give you a really cool icon. But Game Manager is kind of fancy in that case. So here, I'll just do that just because. C# said. Bam, look at that. Isn't that cool? The script itself looks awful, looks the same, looks awfully similar, But yeah, it's an Epic game manager. And of course, I'm going to have to drag that one over to the game manager object. This script doesn't inherit a native class that can manage the script. What happened there? What's that about? It's a mono behavior. The script don't inherit a native class that can manage a script. Well, that's unusual. Yeah, let's come back to that one. I have not encountered this yet. So maybe this is a 2020 thing. And I love the grammar on that one. The script don't. Come back to that. That was weird. Let's go over here. And even I could say, well, add component. And I'm going to say, interesting. Normally, I would be able to just say, hello world, hello Unity. Interesting. Oh, I wonder. Watch this. Show in Explorer. No, it is GameManager.cs. All right, we have to come back to that one. That's acting weird. Okay. It's going to chew up too much of our time to figure out. So anyway, we have the game manager with the correct script on, the hello Unity script on. So that is happening. That's cool. That's the main thing we want to do at this point. And we now have our script running. So that's all fine and good. So let's say, what's next? What is the next thing we want to do? Is we want to connect an object to a script, right? We want to have an actual meaningful event, perhaps, that does something. So let's give that a try. So what I want to do here is now we're going to get fancy. And this is going to become the foundation for our project, right? We're going to have something print here when we press this button. All right. So we're going to show the easy way to do it, or the point and click whizzy way to do it, as opposed to anything too fancy. So we have the game manager over here, and the game manager has this hello Unity script on it. And I'll open that up. And I'm going to use the game manager to hold sort of game management functionality. It's going to be in this script for now, in the hello Unity script. So we're going to create a public. We're going to talk more about public, private, protected, different kind of decorations for the methods in a class. But for now, we're just going to take my word for it. We have to declare it to be public void, meaning that we can access this from other objects. All right, don't worry about which is default and so on, but be explicit. We want to be public void, and this will be, we'll call it button pressed. Right, we use the curly braces, mean that yes, this is a function, and within that function, it's just shorthand. It's exactly the same. Print or debug.log, exactly the same. It's just easy to remember. So button pressed, we're going to say, okay, print. And again, for simplicity's sake, you pressed it. Make sure to put our semicolon at the end. So now we have a button pressed function. And we are faced with the challenge of saying, okay, how do we connect this button function to that button in the scene? So I'm going to say save. And here we go. All right, the challenge. We have this button, and we have the button script over on the game manager. So let's look around. We have this button, and the button had certain components on it. And the functionality of the button itself is going to be within this button component. Hint, hint, right? So if we look at this button component, it is interactable. That's turned on. It has some things, it transitions, it changes text when it is interacted with and so on. Not going to change any of that. The important part is it has this on-click event. It will raise an event when it is clicked on. So what I want to do is I want to make another function, put it on this list of functions to call when this event is raised, when this event happens. Pretty simple to do that. I'm going to press plus. It's a runtime. I'm only going to do this when the game is running. I have to tell it first, which object is this coming from? Which object am I interacting with? I'm going to press the little target. You see, it's going to ask me to select an object. I'm going to make sure I only want to see objects that are in the scene. And I know that I want to interact with the game manager. That's where I'm putting my generic game functionality on that one. Okay, so game manager. You'll see now, okay, that's the object. Let's try to find now a function to call on that object. It's going to go through and say, okay, here are the components on that object and potentially even the children of that object, if we want to get like fancy. No, actually, we're not seeing children. This is just the core game object here. And we want to go to the Hello Unity component. And we can see that there's a bunch of different things on here. But the important one is, where is it now? Why am I drawing a blank? Hello Unity. Did I change it in the wrong one? Did I change it in Hello World? What am I doing wrong? Over here, Hello Unity, public void button pressed. Yes. Yes. The game manager script? No, I have not. I don't know. Okay. I named it as I was going, or just in the normal way, because it didn't. Right. Normally, if this name here inside the script, game manager, if that didn't match this name here, that would be bad. Yeah. That's why that's normally that's the thing I would go to, and that's kind of was in the back of my head. These do need to match. These should always match. If you use a class that doesn't inherit from mono behavior, that is true. We'll get into non-mono behavior classes in a while, so let's not get too all right, we're gonna get there. So let's figure out why my hello world is not being found here. Let's go to the button again. And hello Unity. So did I just wait, Hello Unity has public void button pressed in there. And here's the problem. The game manager has, wait, which has which now? Hello Unity has that in there. Game manager has Hello Unity on it. The button, Hello Unity. You know what? I may very well, let's see, let's rename that. I wonder if I accidentally, sometimes you have to be careful. We accidentally used a name that is reserved. Yeah, that's, I think, what I did. Hello Unity. I still don't have BP. I know exactly what it is, and this is the embarrassing point. See how this little button here is still blue? I'm still in play mode. Bad me. If I'm in play mode, not only do the changes that I make inside the editor potentially go away once I hit that, but these scripts are not being recompiled as I am working on them, even if I'm saving them, right? So that's Everyone will run into that. I just did that for purposes of demonstration. It's 4:20. We better wrap things up. So now that I'm out of here, and now that I go and say, okay, there's button, here's the list, plus, let's quickly do this, scene, don't tell me, all the way back to game manager. That's what totally happened here. All right, so create empty. I wonder if that even will fix that. Yep, that even fixed that. I love when that happens. This is the greatest thing. So, all right, we fixed that. I don't know why it let me do some things and not other things. But anyway, really, really fast. Okay, button. Come over here. Object, scene, game manager, function, hello Unity, BP. All right. Now I press play. And now, if I press me, you pressed it. Okay. Yes. And let me add hello Unity script because it was already compiled, but the game manager script wasn't. That is absolutely correct, right? So the only time it is compiling is when the game is stopped and I go back in again. So that was already in there. That was already compiled. Everything was all good. It liked the state. And the moral of the story, it's a good moral because it happens. I know it happens enough to me that I'm assuming it's going to happen to everybody at some point. It usually is happening in class. I receive that. Be careful to make sure you exit play mode when you start editing and moving things around, because that's important. Okay. So we saw that actually work. Let's jump back over here again and kind of wrap things up quickly. And this will be here, and you can go over this at your leisure. Open up the sample, open up the presentation notes. This is about homework 1, the concepts. Okay. The idea is to have a project that is basically a no video game. It's going to be mostly text based. We want to use the user interface elements to handle input and output to the user as much as possible, and use audio. This is a game called Real Sound. It was for the Dreamcast, worked on many, many years ago with a company called Warp. Really, really cool company. You can use that as a footnote. Look it up on the internet. Basic things to keep in mind. For inputs, we want to have a set of buttons. So use the buttons just like I said here. Arrange them as a D-pad here. Have a left, right, forward, back. Could be north, south, east, west, up, down, left, right. Whatever you want to call them. And you're going to connect them with events to some script. Probably you should have we can keep it simple and just have one, say, game manager object that has most of the functionality in it for now. It's going to be largely turn-based. So there should, in addition to being the movement, quote unquote, with the D-pad there, we want to have some additional button that's going to be some sort of action or resource button. Are you using your flashlight so it's using the batteries up, or can you echolocate by clicking and give you some additional information? Maybe you have text input so the user can enter their name and you can put that in the responses, or maybe sometimes it's going to ask a question, you have to put a response. Maybe you use some other UI elements like a volume slider because we're going to have some background music and whatnot. So for outputs, we want to have some responsive sounds, right? So we're going to do things like a sound will get louder or softer depending on how close we are to our goal or to a danger. Or maybe we bump into a wall, we're going to have some sound. We should have some sort of ambient sound. We might have triggered sound. We should have a description box to tell you kind of what's going on, to tell the story. Because we want a narrative element here, right? We want to really see what we can pack narrative-wise into a very, very small package, but hopefully something unique. We're going to have some output for progress, score, hot, cold. Are you getting hotter or colder? Are you getting closer or warmer? It's kind of Marco Polo kind of approach here. It gets darker, meaning you're further away from the goal, right? It's all about description, telling the story through words and sound. And when the user reaches the goal of the end, there should be something to let them know. Maybe it's text, maybe it's a combination of text and yay, music and sound and so on. If our game is text-based Marco Polo, can our description just repeatedly say you enter a room and you are blindfolded? you're not continuously entering the room. You could say you're still into the room and you are blindfolded. You shuffle your feet, until they hit something, or they move so they feel colder, warmer. Absolutely, that can be part of it. So to be a little bit more, tiny bit more explicit, I don't want people using typical, imagine having a 2x2 grid of potential locations, and then you populate that grid as an array with letters. And if it has a B on there, it's a beast. And if it's an M, it's a whatever. Don't take that approach. I want you to have objects in the scene that the user has to find or gauge proximity that has an X and a Y value. We'll get to that, but we're going to be, using some math in here. Okay. We're going to think a little bit object-oriented wise, even though we're going to do it kind of brute force sort of way. Right? Player and encountered objects, we're going to have a position in the world. We're going to manipulate them directly by clicking on the D-pad. And at your leisure, read through here. Start formulating your design based on here. Right? These might be, at this point, sort of overly descriptive or overly explicit, but this is sort of, the guidelines we've used in the past for the project. If you want to be above and beyond, that's great, but this is kind of the general notion. All right, so let's wrap up there. We're already over time I owe you all 7 minutes somewhere, but thank you for your attention. Sorry for it was a good lesson. That's one of the best lessons, that never edit when you're in play mode. And have a great weekend. Assignment for the weekend is basically, continue, start thinking about this project from a design perspective. Given these things, think about, it's very different. It is not the typical Unity game where you just have objects and move them around and add physics and so on. Right. So for those of you who are very familiar with Unity and have done the normal type of things, this is designed to kind of push you outside the comfort and normal zone a little bit and get a little bit of a better hand with some of the Unity UI elements as well. And also practice a little bit of your narrative development, potentially. All right. Thanks. Have a great weekend. Shoot me any messages. Occasionally, I do like to go out to dinner with, or have dinner home, or maybe watch a movie or something. Usually don't go out to dinner. I haven't been out to dinner in a long time. Our definitions change these days. Yeah. So tonight we're eating in. I think my wife is picking up something from PF Chang's. Yeah, she works in the real world. She works at a hospital. She's already gotten the vaccine and so on. So she's my lifeline to the real world. And I'm, yes, the real world outside these walls. I live in the virtual world. Yeah, that's for sure. So, all right, I'm going to stop streaming at least, so that if you want to continue the conversation, perhaps we can. But at least I won't record it. Let's see. And yeah.